All right, Lab 4 circuits. Introduction. Here's our purpose. Predict the behavior of circuits containing resistors in series and parallel. Use multimeters to measure the actual values of conventional current and potential differences in the circuits, and examine the behavior of ohmic resistors and capacitors using the principles of energy conversion and current conversion, or conservation. Fundamentals: the conservation of energy and charge, Kirchhoff's circuit laws, which is the loop rule and node rule, Ohm's law, which we know is V equals IR, capacitance models. So in this, we used real circuits, which you'll see in the following pictures. Here are the results we found. We found that our predicted values were very similar to experimental values, so our calculations were correct. We also found that voltage is time dependent when we're in an RC circuit. Here's our experiment with our series circuit. So here's our answer to the questions in the lab. We found that I1 is equal to I2, and we got our current was equal to 0.02 amps, which was pretty close. We measured it to be 0.0196 amps. The reversed ammeter reads just the negative version. So for number 4, we found that the current was 0 and that the change in voltage was 3 volts. This is because there's an open circuit, which means that the current is 0, and also that the voltmeter is essentially measuring the potential difference between the negative and positive end of the battery. 7, we found the potential differences from one end of the battery to the other should add up to be the total voltage, so 3 volts. And when we measured this, we got 2.9, which we'll see in the next slide. So here's our graph where we measured the volt differences. So we found from C to D, it was negative 0.9 volts, essentially 1. And then from E to F was negative 2 volts, was our change in potential there, which equals the inverse of our A to B, which was 3 volts. So they add up to 0. The ammeter doesn't change because it has a high resistance, and once again, the ammeter doesn't change. Experiment RC circuit. So our observations with this was that the bulb slowly dims. When we're using just the capacitor, the bulb lights up and then it slowly dims once again. Then we found the current decreases. The current decreases again. The questions are up top here that I'm answering. The charge time was 24 seconds for our 10 ohm bulb, and the discharge time was 15 seconds. We couldn't repeat the experiment because we only had 10 ohm bulbs available. Here's our graphs. So this is our RC circuit, and we found the potential difference versus time right here, and it's like the exponential function. Here's what we have plotted right here, and here's our value. So here's like V naught was 3 volts, R is 10 ohms, and then the capacitance was 0.2 farads. Here's our linearized version, so I just took the natural log here and then plotted this. So there's that. Sources of error, just basic ones. Human error, we might not have measured everything precisely. Poor equipment, and the resistance might have been inconsistent. So for our discussion, if we did this lab with real circuit components, which we did, we're going to talk about how it behaves differently when we do it virtually. So the virtual ammeter would be the ideal one and has a slightly higher current because when we use a real one, it's going to have internal resistance, which is going to lower it. Now, for the other what if question, we're going to see how long it takes to measure or how long it takes to charge the capacitor when it's directly connected to the battery. So it's in the ideal version, which is the virtual one, it's going to be instantaneous, but in real life, it's going to take a little, like a very, very small amount of time, but it's still going to have a short delay because there's an internal resistance in the wires. So that's going to slow it down. All right. Thank you.